Welcome to another session of Kurgateric Finance and Accountancy Tutorials. Today we are going to still continue with what we were doing in our previous session on solving the transportation problems using the various methods that we had highlighted before. And in our previous session, I did show you how to solve this problem or this question that was examined by KASNEB in June 2011, question 3C, using the northwest corner rule. So today, ladies and gentlemen, we are going to solve this problem using what is known as the Vogel's approximation method, the VAM. So that was our second or part B of the same, the Vogel's approximation. This VAM, Vogel's approximation method. So this method normally gives a lot of students headache and more so in solving it. But I will try as much as possible to be to make it simpler for you. So I will still redo what we had done before, just drawing the matrix so that we solve this question from there. Okay. Now, ladies and gentlemen, here we have steps in solving the Vogel's, the question using the Vogel's approximation method. So here we must find what is known as the row and column differences, and then we check the higher from the row and the column, and then we allocate as much as possible to the lowest cost in what we've identified. Are we together? So this is how to do it. So these are row, right? These are row and these are columns. Are we together? So rows, we are going to find the row differences. So here, these are the rows. We are going to call these ones row differences. Sorry, let me write this way. Row differences. Row differences. So and then these ones, these running down are columns. So we are going to say columns differences. Good. So that is what you are going to do. So from the term row differences is that you are going to find the difference of either figures here. But what Vogel states, or what Vogel's approximation method I want us to do, is that we find the difference between the two lowest costs. The two lowest costs here. So the lowest cost under warehouse 1 in this row is 180. 180. 120 is higher than all of them, but you are supposed to find the difference between the two lowest costs. So the lowest cost after identification is 180. So when you find the difference between 180, it's 20. So you write it here, 20. That is what I mean when I say the row difference. You find the difference between the two lower cost. So leave alone 120. 120 is higher than the 2. And then you disregard the supply when doing the difference between the two lowest costs. So remember, supply is not a cost. The costs are here in between the cost of transportation, this supply and this demand. Are you together? So if you understand that, then you can do this one. So the two lowest cost here is 140 and 80. So we have two 140s. You take either. So 140 minus 80 is 60. That's what I mean when you say the row differences. And then you come again 160, 120, 140. The two lowest costs are 120 and 140. So the difference is 20. So don't look, or rather don't calculate, find the differences between the lowest in demand. These are not costs, just the same case we did in the supply. So the next step is to find the difference. In this column, the two lowest costs. The lowest cost here are 100 and 140. So the lowest, the difference is 40. Are we together? So the two lowest here are 80 and 80. Because 120 is higher than the 2. So 80 minus 80 is 0. and then 120 minus 140, because 140 is kind of repeating itself. 120 minus 140 is 20. Are we together? So that is the step 1 in solving the same using the Vogels. So the next step is to pick the highest in the row and column difference. The highest in the row and column difference. So the highest here is 60, which is also still higher. So you check the row and the column. So the one that is highest, the difference that is higher. So the 60 is higher in both sides, the row and the column. So you identify it by doing what? By circling it as such. So since you have circled this one, so it means we are going to play with figures around here in this, okay, in this row of 60. Are we together? Disregard all these others because the ones that is taking the highest difference, the 60. So you check something here. So step number 3 now is you allocate as much as possible in this row of 60, of which this row of 60 is warehouse 2. You allocate as much as possible to the lowest cost. You allocate as much as possible to the lowest cost. That is what I wanted you to understand. That you allocate as possible to the lowest cost. So if from this row, the lowest cost here is 80. From what I see, it's 80, right? So you're going to allocate as much as possible to this 80. So you just identify it by giving it, you write it as such. So then you come here and ask yourself, in this 80, we have, okay, this 80 is warehouse 2, sorry, and then customer 2. So the demand for customer 2 is only 120, but here in warehouse 2, we have a total of 168. So we are going to allocate the lowest, which is 120 here. So you allocate 120. Are we together? So then you say, since 120, this customer will be satisfied. So you say minus 120. So you remain with 0. Are we together? The same case applies here. When warehouse 2 supplies 120 to customer 2, then it will have to reduce and then remain with around 48. Are we together? So this column is complete because where customer 2 has been served accordingly by that warehouse. So since this column is adding up to 0 as far as total demand is concerned, now you are supposed to cancel this one off. So that column is done. Are we together? So, and then we go back again and do what we've done. And that is all about Vogel. So having done that and having crossed the customer 2 column, now we are going to repeat the same thing that we did initially. So let me draw this way because we are done with that. Same case applies to this other side. Yes. So we are supposed to repeat the same procedure that we used in the first place. So we are supposed to find the row difference here for the remaining costs. So we have the cost of 100 and 120. So the difference of 100 and 120 is 20. You write 20 there. Okay, here we are remaining with 140 and 140. 140 minus 140 is 0. Here we are remaining with 160 and 140. 160 minus 140 is 20. Are you together? Here, don't look at these ones. These ones are not included. They are not costs. Right? And then you now come to the column differences. So here we still have 100, 140 and 160. So what do? You find the difference between the two lowest costs. So we have the lowest cost being 100 and 140. 100 minus 140 is 40. Are we together? And then this column, we don't have anything because it's satisfied. We have satisfied that column. We have satisfied the customer 2. And then customer 3, we have 120, 140 and 140. So the two lowest is 120 and 140. So the difference is 20. So this one is done. Are we together? and the same thing will follow, that we are going to look at the highest row or column difference. So in this second row, okay, in this second row difference, we have 20, 0 and 20, but we have in the column difference 40 dash and 20. So here we have 140 being higher in both row and column differences. So we are going to take this 40. This 40 is under this column 1. So the next step is you allocate as much as possible in that column to the lowest cost. So the lowest cost here is 100. It's not 140 or 160. The lowest cost is 100. You allocate as much as possible there. So having identified that is 100 is the lowest, then you draw as such, and then you start allocating. You look at the demand, okay, the supply and the demand here. So the supply here is 260, the demand is 280. You take the lowest. So since the customer 1 demands 280, but what is available in this lowest cost is 260 alone from warehouse 1. So you are going to allocate the full 260 to customer 1 in warehouse 1. But still, this customer will still require, okay, when you less 260, you get 20. We still want 20 from either warehouses, isn't it? So having done that, so it means that, okay, we also less 260 here, so that it remains 0. So this row, we no longer require this row because we don't have anything to supply from warehouse 1. Customer 1 has taken everything there. So we are going to cancel off this way. Are we together? And then the difference here is 20. And then the same procedure will repeat itself. That we look at the row difference here is 0. We don't have anything here. And then in row difference in warehouse 2, we have 140 and 140. When you minus the 2 is 0, right? Because this one you're not going to allocate, we cross that off. Then warehouse 3 is 160 and 140 is 20, right? And then you come again and draw for the column differences. You come and check this column. We're only remaining with 140 and 160 is 20. And then this column we have dash. Then this other column we remaining with 140 and 140, which is 0, isn't it? So we are done. So our next step is to check the highest in the row and column differences. So in this case we have 0, 0 and 20, 0 and 20. So we have a tie of 20 and 20. So in the case of a tie, you pick either. Are we together? So if in case you find that there is a tie between the row and column differences, you take any. So you can take the row for the row 20 or 20 for the column. So in this case, let me take, for instance, let me take this one, the column. So this one, I'll not touch this. Are we together? So in this column, I will allocate as much as possible to the lowest cost. The lowest cost between 140 and 160 is 140. So after identification, you draw this way, and then you start allocating. You look at it this way. That in this column, in this customer 1, we allocated 260, we still have 20. This customer 1 still requires 20 from either warehouses. But we have identified that he is supposed to draw that from warehouse number 2. Are we together? So that 20, you allocate here. So that we minus here 20, we minus 20, we remain with 0. And then you still minus the same 20 here, so that you remain with 28. Are we together? And then still, because this one is 0, so this column is done. Customer 1 is satisfied. Are we together? Since it's 0. So here we are remaining with only 140 and 140 on this other side. Are we together? So here there's not much about the column or the row differences, because you only have 2. And here the warehouse number 2 only has 28 to offer to customer 3, and then the others will go with customer number, okay, warehouse 2 has got only 28 to offer to customer 3, and then the rest 172. Okay, the difference will the customer 3 will draw from warehouse number 3. So here we are just going to write 28 so that we make this one 0, isn't it? So having done that, you cancel off, so that one is balanced. And then we remaining with 172. You allocate as this point, yes, so that when you add 172 plus 28 you get 200. Are we together? So that one is done, right? So ladies and gentlemen, and then you come here and say 172, which is 0. So you can see how simple it is. So ladies and gentlemen, this is again what you do. This 178, you less 28 here, and then you less 172 here, so that you get to 0. Are you together? So ladies and gentlemen, that is simply what you're supposed to do when solving the transportation problem using the VAM, or the Vogel's approximation method. This is how to go about the same. Looking for the row and column differences, you check the higher, okay, in row and column differences, and then in that row or in that column you allocate as much as possible to the lowest cost, lowest transportation cost. So I want to believe that is simple. Now the next step is to find the cost. Just the same way that we did for the northwest corner rule, we are going to find the total transportation costs, right? So the total transportation cost, so let me delete this one, how to get enough space. So meaning our total transportation cost then will be, for warehouse 1 and customer 1, warehouse 1, customer 1 will be 260 times 100 cost. So 260 bags of rice, you multiply by 100, which will give us 26,000. Okay, together. And then you move to warehouse number 2, customer 1. Warehouse number 2, customer 1 will be 20 times 140. 20 times 140 will be 2800. And then you move to warehouse 2, customer 2. Warehouse 2, customer 2 will be 120 times 80 times 80 will be 9600. And then again we come here and say 172 times 140. This is warehouse number 3, customer 3. Customer 3 will be 172, you multiply by 140, and then you say 28, that is warehouse 2, sorry, we skipped that. Customer 3 is equivalent to 28 times 140. This is around 3920. This was 24,080. So when you add all of them, you get 66,400. So this is the total transportation costs using the Vogel's approximation method. So in case of any question, ladies and gentlemen, please do not hesitate to get in touch with me with the contact details provided, right? So make sure that you rewind this session as much as possible until you get to understand this one. So I want to believe that I have done justice to Vogel's approximation method, being a method of solving a transportation problem. So if you are not subscribed to the channel, please do so, right? And also recommend it to your friends. Give it a thumbs up and make sure that you share. So in our next session, we are going to look at solving the same problem the KASNEB June 2011 question 3C using the last method of solving transportation problem, and the method is least cost method, right? So until then, it's goodbye for now.